This is it, the most exciting new automobile in America. The beautiful new DeSoto, with the most exciting new engine in America. The 160 horsepower Fire Dome V8 engine.
Here is an entirely new kind of automobile engine with hemispherical or dome-shaped combustion chambers that produce more work per unit of fuel than any other automobile engine.
This means that the DeSoto Fire Dome 8 gives you plenty of reserve power and acceleration at all speeds and on regular gasoline. And notice that attractive air vent hood that directs an added stream of cool air right to the carburetor for even greater engine power.
So stop at your DeSoto Plymouth dealers tomorrow and try this great new car from behind the wheel.
The new 160 horsepower DeSoto Fire Dome 8.
Hi, everybody. This is Horsepower Heritage. I'm Maurice Merrick. Thanks for joining me once again, and this week we're talking big cubic inches. HEMI, the Chrysler Hemi, a legendary engine, and you're going to learn today where it all began. And before we get started, I just want to remind you, if you enjoy this show, go to buymeacoffee.com/HP Heritage. Also, don't forget to follow Horsepower Heritage on Instagram as well as YouTube. There's lots of great videos over there for you. All right, we're going to get started. Get your helmet on, get your fire suit on, strap in, because today it's all about the Hemi, HEMI, Chrysler's post-war powerhouse. Enjoy. Lincoln, Alabama, March 24th, 1970. A light but steady rain is falling, and to the southeast a few miles, the surface of the track at the Alabama International Motor Speedway is wet and slick. A team of engineers and mechanics from Chrysler Corporation are waiting in the pits for the weather to clear so they can fire up a hot new test car. It's a highly modified Dodge Charger with a beak-like nose cone and a massive rear wing. Under the hood is a 426 cubic inch Hemi V8 pumping out 575 horsepower. They call it the Daytona, and they've brought it to Alabama to set a new record, 200 miles per hour or better. The Speedway is only a year old, and its first season was not a good one, despite the grand plans of its developer, Bill France Sr. And he wasn't just the builder of the track, he was the founder and owner of NASCAR. His ambition was to create the greatest venue in racing, even better than the Daytona International Speedway, which he built in 1959, and faster than the Indianapolis Motor Speedway. In fact, he wanted Alabama to be the fastest motor racing course anywhere in the world. France was able to acquire a decommissioned military airfield near the Talladega Mountains and carve out a 2.66-mile course configured in what's known as a triangular oval, sort of a combination between those two shapes, triangle and oval, with a steep 33-degree banking in the long sweeping turns and 16.5 degrees in the triangle section of the oval, and 2 degrees on the straights. But despite Bill France's grand plans, things weren't falling into place. The combination of sticky new asphalt, high speeds, and high banking angles exceeded the limits of racing tire technology. Enormous loads and high temperatures were causing even the best Firestone and Goodyear tires to blister and delaminate with just a handful of laps. It was just too dangerous, and someone was going to get killed. So the weekend before the inaugural race in 1969, NASCAR's top drivers tried to negotiate with France. They suggested that all the cars be run with restricted carburetors to limit top speed. But France wouldn't budge. He was the boss. He wanted to show the fans how fast the track really was. There was an argument about the whole thing, and France told driver Bobby Allison, "If you're scared, go home." At that moment, another driver, Leroy Yarborough, took a swing at France, caught him in the chin, and knocked him off his feet. And then everyone loaded up their cars and went home. On race day the next weekend, all of those top drivers boycotted the race. Bill France was stubborn, but he wasn't foolish. In the months that followed, more paving work was done to improve the Alabama International Motor Speedway in preparation for the 1970 season. France had basically sunk his entire fortune into making this new track a success. So with less than a month to go before the 1970 Alabama 500, he was in dire need of some good press, and the spectacle of the Dodge Charger Daytona setting a new speed record would be a big win. The rain let up late on the morning of March 24th, and the track dried out. The Dodge team fired up their beast. It was painted a bright blue with the number 88 hand-painted in silver on the roof, and across the hood, 426 CI called out the massive Hemi engine. Driver Buddy Baker strapped in and took a few warm-up laps, and then he put down the hammer. And by late afternoon, he'd run a lap at 200.44 miles per hour. Faster than Daytona, faster than Indy, faster than anyone anywhere. Finally, Talladega was on the map.
This was Buddy Baker, a top NASCAR stock car driver, on Tuesday of this week at the new 2.66-mile Alabama International Speedway in Talladega, Alabama. During runs conducted for transmission testing, Buddy became the first man in history to break the 200-mile-per-hour barrier on a closed race course, and you're watching him do it here in his winged Dodge stock racing car. At full speed right now, flat out at Talladega. The Talladega is an ultra-fast track, the fastest in the world, as a matter of fact, and on this run, Baker averaged 200.096 miles an hour. Out of Turn 3 and on the high banking going into Turn 4. Part of the reason for the high speeds at Talladega, of course, is the exceptionally high banking, which is 33 degrees. Buddy Baker achieved this awesome lap after several warm-up tours of the course, and afterwards he came back out again and did even better, 200.447, and there he is in the home stretch. Buddy Baker at 200. After the run, Roger Baer, the Speedway's public relations director, asked Buddy how it felt to be the first man to break the 200-mile-per-hour barrier.
Gosh, it's the most wonderful feeling I've had in a long, long time. There's something that nobody can ever take away from you, being the first guy to run 200 miles an hour on a closed course circuit, and gosh, I'm just tickled to death.
Buddy, the racetrack is different than most other racetracks in the world in that it's banked 33 degrees, 5 stories high are the banking, and it's 2 2/3 miles around. That's bigger than any closed course that you run wide open like this.
Well, believe me, when you're running 200, it feels just like it's flat because it takes every bit of the banking to run this speed, and we're just tickled to death to be able to come down here and break the record. Thank you.
The 426 Hemi put Buddy Baker into the history books. But let's go back to where it all began. Just what is a Hemi anyway? Well, it's all about squeezing more power from an engine. For example, you can make each cylinder bigger for more displacement, or you can add more cylinders, or you can increase the compression ratio. Those are all ways to do it, but there are practical limits to those options, and early automotive engineers recognized the need to make each power stroke more efficient. When a piston compresses the fuel-air mixture, the swept volume of the cylinder pushes everything into a tight space at top dead center. And that space is called the combustion chamber. It's where the surface of the engine block meets the space inside the cylinder head. The intake and exhaust valves are closed, and when the spark plug fires at just the right moment, detonating the fuel-air mixture and pushing the piston down on its power stroke, well, there's the magic. But several things influence the efficiency of that detonation, like the shape and the volume of the combustion chamber, the location of the spark plugs and the valves, and the shape of the piston crown. Without careful consideration of these factors, much energy can be lost. Not doing any actual work, but instead simply generating heat, and it gets lost right out the exhaust, or into the block where it's transferred into the coolant and out the radiator. The hemispherical combustion chamber addresses all of this. The chamber is shaped like a bowl, not quite half a sphere, as the name implies, more of a quarter sphere or less in many cases. Intake and exhaust valves are set across the bowl from one another, unlike more conventional combustion chambers where the valves are side by side. And the spark plug is set in the center of the bowl. So in practice, this can mean a few things. First, better gas flow because the valves are opposing each other, and fresh air can enter on one side of the engine, and then the exhaust gases can leave through the other side. And because of the chamber shape and the central spark plug, the flaming combustion spreads evenly outward from the point of ignition in a radial fashion. There's no single father of the hemispherical combustion chamber, by the way. Engineers in Europe and the United States were experimenting with these ideas independently as early as the 1890s. For example, the Welch Motor Car Company of Chelsea, Michigan, built the first American car with a Hemi engine in 1903, and a Belgian manufacturer called Peep was selling their own design the following year. In 1913, Peugeot racing engines were using a sort of Hemi head. It was technically what's known as a pent roof design, but in practice it gave the same advantage of large valves, cross-flow breathing, and a central spark plug. And in 1927, another French automaker, Delage, pulled out all the tricks to produce a 1.5-liter straight-eight Grand Prix racing engine that made 150 horsepower, a remarkable number for the time, especially from that displacement. And it had gear-driven twin camshafts, hemispherical combustion chambers, and a roller-bearing crankshaft with no less than 9 main bearings. Another example, Taubo Lago developed a powerful 3-liter straight-six Hemi in 1934. And the BMW 328's 2-liter inline-six of the 1930s was a Hemi too, a design which lived on into the 1950s in Bristol cars in England, as well as AC cars, for example, the AC Ace and AC Asica. And as you know, the Ace was the basis for Carroll Shelby's Cobra. But Chrysler's experimentation with the hemispherical head began in 1939, when the United States Army sent out a request for proposal to develop a powerful new engine for fighter aircraft. It was an ominous sign that before too long, the United States government expected to be fighting Germany and Japan in the air. The requirement was for a 2,000 horsepower engine with minimal frontal area, anticipating the need for a streamlined fuselage design and high-speed performance at high altitude to counter planes like the Messerschmitt Bf-109. Chrysler engineers drew up plans for a liquid-cooled, turbo-supercharged, inverted V16 engine, developing an estimated 2,500 shaft horsepower. They called it the XIV 2220, denoting experimental inverted V and 2,220 cubic inches. It also had hemispherical combustion chambers. The XIV was actually 2 V8s mated together, with a reduction gearbox sandwiched in between. And the reason for this is because a full-length V16 crankshaft and its bearings would be unlikely to withstand the stress. So instead, a drive shaft led from the reduction gearboxes to the propeller. And incidentally, Rolls-Royce encountered this same stressing problem when they developed the Rolls-Royce Merlin V12, which also used a reduction gearbox. The Army awarded Chrysler the development contract in 1941, and over the next 3 years, a small run of XIV 2220s were built at a cost of $14 million. It was a behemoth of an engine, 16 individual cylinders mated to a one-piece cast aluminum crankcase. One of these engines was mounted in the airframe of a Republic P-47 Thunderbolt and flight tested in the summer of 1945. And one of the chief Chrysler men on the project, Carl Breer, recalled in his memoirs that the pilot was so pleased with its performance he actually did a barrel roll over the field and got in trouble for it. In fact, after he landed, they ordered the engine to be torn down to check for oiling problems. But by that time, the project was moot. Germany had surrendered that April, and it was clear that jet propulsion was the future. With the defeat of Japan in August and the end of the war, the program was canceled. The XIV 220 was also inherently flawed by its own complexity, but Chrysler engineers saw the future potential of the hemispherical head as one design element. Now keep in mind, the American auto industry had put their main business on hold during the war. But throughout that period, every carmaker was doing what they could to plan for the future. Pent-up consumer demand for cars was tremendous, but no company had an all-new car ready to go. It was costly to convert back to peacetime manufacturing, and there were critical decisions to be made in terms of capital expenditure. Would it be focused on powertrain, body and chassis, or spread out over everything at once? In April 1946, just 8 months after the war ended, Studebaker Corporation beat everyone to market with a modern and stylish lineup for the 1947 model year. Their advertising slogan was, "First by far with a post-war car." Now, they did indeed have an all-new chassis and body, but the Flathead 6 engines were still a holdover from the pre-war product line. General Motors and Ford didn't have all-new cars ready until 1948 and 1949, respectively. Scooping everyone, Cadillac and Oldsmobile each had an all-new overhead valve V8 in 49. But like Studebaker, Ford stuck with its aging flathead V8 for a few more years. The smaller manufacturers like Nash, Hudson, and Packard struggled more than ever to compete. And Chrysler, well, they were sort of in the middle. They were trailing Ford and GM in sales, and Chrysler was a very conservative company with largely conservative styling, and it had been burned by the failure of its avant-garde and streamlined Airflow line of cars in the 1930s, which were supposed to be the next big thing, but turned out to be a commercial disaster. So given that history, the first post-war Chryslers were just facelifted versions of the 1942 models, and they sold fairly well. But the question remained, what would replace their aging flathead straight 6s and 8s? The answer came from an engineer named James Zeter. His elder brother Fred was one of the so-called Three Musketeers, along with Owen Skelton and the aforementioned Carl Breer, whom Walter P. Chrysler hired away from Studebaker to launch his company in 1923. Now, Jim Zeter knew that the success of the next engine depended on maximizing thermal efficiency, and he believed that the hemispherical combustion chamber was the key because it inherently provided for cross-flow breathing, large valves and ports, higher compression, and greater power and fuel economy. And he knew about the designs of the 1904 Belgian Peep, the 1913 Peugeot, the 27 Delage, and the 1938 BMW 328, those cars that I mentioned earlier. Now, there were already single-cylinder Hemis being tested in the engineering department, and in 1948, Zeter modified a Chrysler Flathead 6 with a twin overhead cam Hemi head. His experiment was a success, and he went to the board of directors with a proposal, a compact Hemi V8 that would be the basis of Chrysler's new engine families. His brother Fred rejected the idea, saying that the straight 6 was Chrysler. But Chairman K.T. Keller was in favor of the idea, which was a surprise given his normally conservative approach. And just to give you another example of how conservative Keller was, he resisted curved glass windshields until 1953. They were using 2 flat panes of glass kind of set in a V formation, and it made their products look dated far past everyone else, even Ford, which had a similar windshield but a much more modern body. Anyway, this new V8 project would be Chrysler's first production overhead valve engine, and some significant engineering challenges were in store. The first challenge was in the pen and ink phase, the layout, specifically the valve train operation. One inherent requirement of a Hemi is that because the intake and exhaust valves oppose each other, think of them as sitting at 3 o'clock and 9 o'clock, They have to be physically and mechanically separated. On an overhead cam engine, it's simply a matter of having a cam for each set of valves, exhaust and intake. But overhead cams would be too expensive, so this engine had to have push rods. The tricky part was how to get the push rods to reach the rocker arms of the exhaust valves, which are on the outboard side of the head. And keep in mind, a Hemi head is much wider, and the push rods needed to run parallel from deep in the camshaft valley through the block and head, and finally reach each rocker arm with a 58.5-degree separation between the exhaust and intake valves. It's a geometry problem. And another thing that threatened the entire program was that the prototype engines were wearing out their camshaft lobes almost immediately. It was a severe setback, and the engineering lab worked for months to solve it. Some of these engines weren't going 100 miles before the camshaft lobes were worn beyond repair. But the Chrysler engineering lab did some changes in metallurgy and lubrication, as well as regrinding the profiles of the cam and the lifter mating surfaces, and that finally cured the issue, luckily. And finally, another inherent design feature that presented a challenge was the depth of the spark plug wells. Because the plugs are seated at the top of the combustion chamber, they drop down through the center of the cylinder head, and that means right through the center of the valve covers. This required special steel tubes and O-rings to isolate the plugs from any oil contamination. In the great scheme of things, it was a fairly minor design consideration, but not to the end user, not to the mechanic or the owner who wants to easily change his plugs and not fight things. And they actually did a really elegant job of addressing this problem. And if you look at a Hemi head and you see those plug wires going into the valve covers, it's very distinctive. You know immediately that that's a Hemi. The new engine was finally ready by the fall of 1950 for the 1951 model year, and it came as standard equipment in the flagship Chrysler New Yorker and Imperial. They dubbed it the Firepower. 331 cubic inches, 180 horses, and 312 foot-pounds of torque at just 2,000 RPM. Hot rodders immediately recognized a good thing, and they wanted to get their greasy hands on the 331, but there was no such thing as a crate engine yet. Their only hope back then was to find a wrecked car with a good engine, and plenty of them did. In 1952, DeSoto got its own 276 cubic inch version called the Fire Dome, a reference to the domed shape of the combustion chamber, followed by Dodge, who got their Red Ram version in 1953, the smallest of the Hemis at 241 cubic inches. The appearance of these engines started the horsepower wars of the 1950s, leading to all sorts of performance options and ever-increasing displacement. The competition took notice. Ford's Y-Block V8 came in 1954, so called because it had a deep piston skirt at the base of the engine block, so from the front or the back it's shaped like a Y. And Chevy famously answered the challenge with the small block 265 V8 in 1955, and then of course the 283 in 1957. As for Plymouth, that division went its own way with a variation called the polyspherical head, where the combustion chamber was actually two overlapping bowls and the spark plug well was offset rather than centrally located. And this allowed for the intake and exhaust valve rocker arms to share a common shaft, and it was also cheaper to manufacture. For this reason, you might hear the Plymouth Poly engines referred to by their nickname, Semi-Hemi.
After World War II, the nation began developing a case of acute congestion that cost us millions of dollars a year in time, equipment, and lives. By 1956, there were more than 65 million cars on our roads, with 90 million forecast by 1975. Clearly, it was a time for national action. Congress responded with the Federal Aid Highway Act of 1956, providing the staggering sum of $51 billion to be spent by the states on highway construction by 1971. The most talked about phase of the act is the interstate highway system, a 41,000-mile network of our most important roads. Most of these roads will be 4, 6, even 8-lane expressways constructed for through traffic. They will take the over-the-road driver from city to city, coast to coast, at highway speeds, even through large population centers.
The development of the interstate highway system in the 1950s, as well as the increasing popularity of drag racing and stock car racing, made V8 performance the dominant feature of the American auto industry. And this was a time when the rest of the world thought 1600 cc's was a big engine. Fast forward to 1964. A banner year for the Hemi, with the 426 cubic inch big block being unveiled and available exclusively for racing. And guys like Richard Petty and Don Garlits proved its prowess. Petty won the Daytona 500 for the first time in his bright blue Plymouth Belvedere, leading for all but 6 of 200 laps. Big Daddy Garlits won the NHRA Nationals with a 7.67 second run at 198 miles per hour in Indianapolis. And interestingly, it wasn't until the release of the 426 Big Block that Chrysler Corporation finally referred to it as a Hemi, which makes sense because it's hard to explain a Hemi in a magazine ad. Firepower and Fire Dome were much more provocative. The 426 Race Hemi was so dominant in 1964 that Ford Motor Company filed a protest with NASCAR, arguing that since the engine wasn't available to the general public, it was a rules violation. And NASCAR saw Ford's point, and they banned the 426 for 1965. In protest, Richard Petty and others boycotted NASCAR, and they went drag racing instead the next season. But the tables turned almost immediately on Ford. This was like instant karma, because in 1965 they tried to run a special overhead cam version of their 427, to which NASCAR said, "Not so fast," and they banned it as well. You get what you give, right? In 1966, the 426 was finally available in street trim. In fact, they called it the Street Hemi. But this sort of set the tone. It was like that all through the 60s. The muscle car wars were nonstop. GM and Ford and Chrysler flaunted their cubic inches and their performance options. And of the big three, Chrysler definitely had the most fun in their marketing, with macho names like Charger and GTX and Super B and so forth. Less than 10,000 customers ever checked that 426 Hemi box on their order sheet in the 5 years that it was an option. But all the racing wins and the NASCAR controversy certainly helped sell plenty of lesser-equipped Chryslers and Dodges and Plymouths. In fact, I'm sure a lot of Dodge Slant 6s were ordered by people who really wanted a Hemi but just couldn't afford it. And that brings us back to Buddy Baker and his Talladega speed record on March 24th, 1970. That's where we began, because with the combination of the Dodge Charger Daytona and Plymouth's own winged warrior, the Superbird, 1970 might arguably be the high watermark for the Hemi story. That season in NASCAR, Richard Petty had 18 wins. His teammate, Pete Hamilton, took the Daytona 500 and the Alabama 500. Bobby Isaac won the Drivers' Championship, and Dodge won the Manufacturers' Championship. I mean, it was the season to end all seasons for Mopar. The next year, Bill France, stubborn as he was and independent as he was, changed the rules, limiting displacement to 305 cubic inches and essentially banning aero modifications like wings and nose cones like you'd find on a Superbird. In 1973, the OPEC oil embargo caused a fuel crisis in America that killed the muscle car, at least for a while. More recently, in the 2000s, the modern Gen 3 and 4 Hemis were once again sort of a semi-Hemi because the combustion chambers were no longer truly hemispherical, and they still aren't. But things like twin-plug ignition and variable valve timing kept the performance moving forward, and technology moves on after all. The new Hemi has been a signature of Dodge Ram trucks in modern times, and in fact, the truck segment of the market has become a new performance trend. I mean, just look at the Ford Raptor. And the Dodge Hellcat has revived the traditional idea of the muscle car. In the last few years, with the push toward EVs, it looked like the Hemi and maybe all internal combustion engines were living on borrowed time. But as I've said before, their death has been greatly exaggerated. And recent rumors are that Chrysler's parent company, Stellantis, is not giving up just yet. So let's hope the Hemi lives on. That's all for this episode of Horsepower Heritage. If you like what you've heard, go to buymeacoffee.com/HP Heritage and become a patron of the show. And also, don't forget to tell your friends about Horsepower Heritage, write a review on your favorite podcast app, give it 5 stars, let us know you're out there, and help new listeners discover the show. I'll see you back here on Wednesday, May 28th for more of the people and stories behind the machines. So until then, I'm Maurice Merrick. Thanks for listening.